Today we're going to talk about exponential and logarithmic functions. We're going to be solving exponential equations using the logarithmic property. So I'm going to write down the steps for that. The first thing you're going to do is rewrite the equation with the base and the power on one side. Step 1, rewrite the equation with the base and power on one side. Number 2, we're going to convert the exponential to a logarithm. So take it from exponential form to logarithmic form. Then we're going to evaluate using the change of base. It's hard to write on this laptop. And step 4, continue to solve if needed. All right, so rewrite the equation with the base and power on one side. We're going to convert it from exponential to logarithm. Then we're going to use our change of base formula to simplify and go further if necessary. So let's practice a few of these. It says solve the exponential equations. We're used to seeing the exponent on the left side, so I'm just going to flip it over and say 10 to the x is equal to 1500. We're going to rewrite the equation with the base and power on one side. Now I'm going to take that in step 2 and I'm going to convert it from exponent to logarithm. So this would become log base 10 of 1500 equals to my exponent of x. Step 3 is to use my change of base formula. So I'm going to do log of 1500 divided by log of 10. And if I pull up my calculator, we're going to say that log of 1500 divided by log of 10, we get 3.176 as our answer. Let's do another example. In part B, E of t is equal to 462. So I'm going to say, since it's already, step 1 is already satisfied, we have our equation with the base and power on one side, I'm going to write it as a logarithm. So log base E of 462 is equal to my exponent of t. So now my change of base, the log of 462 divided by the log base of E is going to give me my answer. So let's put this into our calculator. Log of 462 divided by log of E gives me an answer of 6.136. We're going to round that to 6. 6.136. Remember, when you're doing your My Math Lab, you're going to have to make sure that you round correctly. Again, in part C, I'm used to seeing the exponent on the left side, so I'm just going to flip that around. E to the 5x equals 8,985. So now we're going to write it as a log. Log of base E of the answer, 8,985, is equal to my exponent of 5x. So on the left side, you're going to do the change of base. Log of 8,985 divided by log of E equals 5x. So take out your calculator. We're going to say log of 8,985 divided by log of e gives me 9.1033 equals this time 5x. So I'm trying to solve for x. So how would you solve for x? You would divide both sides by 5. So you're going to take your answer and you're going to divide that by 5. So the answer to the problem is 1.82. We're going to take that and we're going to round up to 1. So 1.821. Look at the difference between C and D. In D, there's a number 3 in front. Remember, step 1 is you have to get the equation with only the base and the power on one side. So before we begin to work number D, I'm going to divide both sides by 3. When I divide both sides by 3, I get E, 8 to the x, is equal to 272. That's 816 divided by 3. Now I'm going to rewrite it as a logarithm. Log base E of 272 is equal to my exponent of 8x. Then you're going to do your change of base form. Log of 272 divided by log of E is equal to 8x. So put that in your calculator. Log of 272 divided by log of E. So I get 5.605 equals 8x. And to solve for x, we're going to divide both sides by 8. So when you go back to your calculator, you'll see that that is 0.701. So E is going to begin the same way. I'm going to need to get the base and the power by itself. So let's divide both sides by 500. So 8,000 divided by 500 is 16. Those are going to cancel out and gives me 10x. So we're used to seeing 10x equals 16. So this is log base 10 of 16 equals x. So we would say log of 16 divided by log of 10 is equal to x. So I'll put this into the calculator for you. So log of 16 divided by log of 10. So we get x equals 1.204. The last one, the number in the base is already by itself, so we're just going to write it as a logarithm. Log base 4 of 32 equals x. So we're going to do change of base. Log of 32 divided by log of 4 is x. So put that in your calculator. Log base 32 divided by log of 4. We get an answer of 2.5. Number 8. The number is raised to a power, so we're just going to write it as a logarithm. Log of 8 of the answer 51 is given to my exponent, no matter what it is. And you just do change of base. Log of 51 divided by log of 8 is equal to negative x plus 4. So go to your calculator. We're going to do log of 51 and we're going to divide by log of 8. So moving over here, we get 1.8908 is equal to negative x plus 4. So we're going to solve for x. So if I'm adding 4, I'm going to subtract 4 from both sides. So these cancel out, and I get negative 2.10919 equals negative x. So I'm going to divide both sides by negative 1. So x would be positive 2.109, rounding to 3 decimal places. Now we're going to go in the opposite direction. We're going to solve logarithmic equations using equivalent exponential forms. Okay? So number 1, here are your steps. We're going to rewrite the equation with only the log, single log, on one side. So it's very similar. Then you're going to convert the logarithm to an exponential. Number 3 is to evaluate the exponential. And 4, continue to solve if needed. Okay? So let's try these. Rewrite the equation with only the single log. Look at part A. I already have a single log, so we're going to write it as an exponent. 4 raised to the first power is equal to x. So what's x equal to? 4. Look at part B. I want to get a single log, so I have to move everything that's not part of the log to the other side. So that means that the 4 has to go to the other side. Since it's positive, I'm going to subtract it. So I'm going to subtract 4 from both sides. So 9, let me write that so you can read it. 9, the natural log of x, is equal to 54. Since this is 9 times the natural log of x, I can divide both sides by 9, trying to get the natural log by itself. So the natural log of x is equal to 6. Remember that the natural log means log base e of x, which is equal to 6. So if we solve this, we want to rewrite it as an exponential function. E to the 6 is equal to x. I'm going to make you a note here. My math lab wants you to type the exact number. Using e. In other words, don't go into your calculator and say what e to the 6th is. Your answer in my math lab will be e to the 6th. In these, when we're rewriting this as a single log, sometimes you're going to have to go back to those properties that we've talked about earlier. Let's look at example C. I want to take this, what I know about expansion and condensing, and rewrite this as one single log. If I'm adding, I know that I can take those same things and I can condense them by multiplying. So log base 3 of x times 15, which is 15x, is equal to 1. So I've rewritten it as a single log. That is step 1. Step 2 is to write it as an exponent. So 3 to the first is equal to 15x. And how would I solve x? Since it's x times 15, I would divide both sides by 15. So x is equal to 3 over 15, which of course can both be divided by 3, and I reduce that to 1/5. What do you think you would do to number D? Step 1 says to get the logs together in one single log. Well, if I'm going to get them together in one single log, then I'm going to have them on the same side. So I'm going to move log base 5 of 7 over to the left side. Just as if I was moving anything over, I would do the opposite. So since that's positive, I'm going to subtract log base 5 of 7. When I subtract log base 5 of 7 over here, of course, that goes away. And I'm just left with 3. We're going to go back to our condensing properties. If I'm subtracting, I can divide. So log base 5 of x divided by 7 is equal to 3. Now you're going to convert that to an exponential form. 5 to the third is equal to x over 7. Well, 5 to the third means 125. So to solve for x, if I'm dividing by 7, I can multiply both things by 7. And so x is equal to 125 times 7, which is 875.